Welcome. Today is Monday, April 13th, after our spring break, or spring review session, more like it. We are ready to go and get ready to prepare for the AP tests that are coming up. And we'll continue to modify our schedule as we see it, as things keep changing and evolving. Not sure when we're going to come back to school. Maybe it's March or May 1st. Could be later. I don't know. Nothing has been said yet. Let's see. So I've opened up Canvas. You will be uploading your spring break homework onto Canvas. Everything should be done by hand. Right. Go ahead and take pictures of that and save it as a PDF and upload it onto Canvas. And then we can get some points. It is due today, I believe. I hope you didn't just put off all of your work and did nothing over spring break. That would be bad. But technically it's only 2 exams, right? So 6 hours, you can get it done. Theoretically, it is possible to one-shot it. Now, we have lots of new information regarding the AP1 test. So I will share them with you. In the next couple of days, we will prepare ourselves to take the test online. And I'll even do, eventually I will do a tutorial on the system that they are using for your test. But today, just light information, and then we'll talk about the homework a little bit. Starting tomorrow, we'll get into the nitty-gritty details about the new way of taking a test, the AP test at least. All right, so dates have been shifted. The dates have been shifted. AP Physics 1. Let's use a thicker font. There we go. AP1 is May. It's on a Thursday, May 14th. We're week number 1. May 14th, and our test starts at 1 p.m. Pacific. Okay. Well, we're getting lots of questions already. Very cool. When is our final? The answer is it depends. If school starts again, if we come back first, then our final is May 7th through 10th. If school does not, we will push the final back to actual finals week. However, new to this year, the College Board will release the results or whatever you got on the 26th of May. Therefore, whatever you do, however you do on this AP test, I can use that as a grade for your semester. So your AP test will go into your grade. Because the College Board will give us the results by May 26th, which is cool, right? So again, if we come back to school as it's currently planned, then it would be May 7th through 10th. If we don't, then it will be in June on finals week. Is the AP... yeah, we have lots more details to cover, so anyway, let's keep going, and I will answer all these questions. We will see. I thought they were just sharing our answers with our teachers. Are they sharing the scores too? I thought scores were coming out in June. Well, I don't know. We'll see. Worst case scenario, I grade it. That's the worst case scenario. And I'd grade it even harder. Alright, AP1, May 14th, 1 p.m. Pacific. It is an online test. Okay. College Board will send you information on how to log into their system. So College Board send info. This is it's the same email that you use to register your My AP. So hopefully you used your school email. Same email for myap.com. And so College Board will send you information, like login information, and then you would log in through that. It is assumed to be open notes / book. However, you are not allowed to consult with anyone. No outside help. No looking online. Honestly, you shouldn't be using your book anyway, but whatever. Now, this is what our 3-ring binder is for, so use 3-ring binder. So if you put your 3-ring binder nicely and neat, this is going to serve you well. So use the you can use your 3-ring binder. It has everything you need pretty much. So it is assumed that you're going to use your notes, so they are designing the questions so that it is not knowledge based. So it's not just like, what is this, what is that. It's more about understanding concepts and your ability to apply concepts. So some people might be like, oh my gosh, it's open notes, it's a joke. Well, I mean, it's not necessarily. It's just there's pluses and minuses to everything, really. In one way, yeah, it's good, but in another way, there could be some negatives, and we'll talk about those negatives. So again, it will be May 14th, 1 p.m. Pacific. That's when it opens up for you, and then you're able to start the process. It's 2 questions. See, these are the negatives. It's literally 2 questions, kind of like our quizzes where you have like 1 question worth everything. But, so I guess I prepared you well. It's 2 questions, 2 FRQs. One, well, the first FRQ, let me pull it up. It's 25 minutes, and then the next one is 15 minutes. Where is it? There, let me pull it up. Physics 1. There it is. Alright, so it's 2 questions. Number 1 is 25 minutes. So the question opens up and the clock starts ticking, similar to how you've been taking quizzes on Canvas. You can't go back and forth, right? The questions lock up. So I'm glad we did that for our Canvas quizzes. So you get 25 minutes. There's a clock that's counting down. And then you get 5 minutes for the so 25 minutes for the question, and then you get 5 extra minutes to upload. This means that you can technically do the question by hand, write it as neatly as possible, and you can. They said you can take a picture of your work with your phone, and then you would send the image to yourself, to like your email or whatever it is, to your Google Drive, and then you can upload like an attachment to an email. You would upload that file and then submit it within the 5-minute time frame. Or you could just do it on the computer itself, type up everything as best as possible, just like you did on your Canvas. Some of you even did like FPDs by typing it out, and then submit that. So that also works, right? So 25 minutes for the first question, which is worth 60% of total. Right, and question number 2 is 15 minutes long for the question, and then you get another 5 minutes to upload. Okay, and this is worth 40% of total. Okay. The first question will be similar to a full-on FRQ that we've done. This question assesses students' ability to translate between quantitative and qualitative justification and reasoning. So think Tipper's. So look through Tipper's style. And this is why the word justify was used so many times in your tests. I've bolded it, I've underlined it. A lot of times we miss it anyway. So lots of justification, reasoning. There are also other types of Tipper's questions, right, where they will give you justifications and reasoning, and then your goal is to analyze those justifications and think about what is wrong with the justification, what is right. Sometimes we mess up by just stating true facts, and just because you state things that are true doesn't necessarily mean that it answers the question, right? So those happen all the time. Those are classic strategies that the College Board would use. So just because something is true doesn't necessarily mean that it answers the question. So you want to figure out what justification is actually true and what justification actually answers the question or the prompt. And the second question is a paragraph question. So in a paragraph length response, this question type assesses students' ability to create a paragraph length response, which consists of a coherent argument about a physics phenomenon that uses the information presented in the question and proceeds in a logical, expository fashion to arrive at a conclusion. Wow. All right, so the second one is completely just pure paragraph. And the first one is more Tipper style, justify. I'm assuming there are going to be multiple parts to the first question. Probably like a lab design could also be there, and then you would do some reasoning why you chose this method over that method, perhaps talking about how to reduce errors, things like that. Is each question going to be like a certain amount of points? This is the grade breakdown. First question is 60%. The second question is 40%. If you're asking about like raw points, like they used to do, they did not actually give us raw points. So whatever the raw points are, 60% of the raw points would be from the first question and 40% from the second question. So 7 equals 0.4 times x. 7 over 0.4. Let's see. 7 divided by 0.4. Okay, so if I use like the normal, oh, what happened? Something happened. All right, we're back online. If I use the normal point scale, right? Typically the paragraph length response question, kind of like number 5 on your practice test. The paragraph length response question is worth 7 points. So if the paragraph length response is held to the same 7 FRQ points as the original test, then this first question would be worth 17.5 points. So it's to that order. But the points are kind of arbitrary at this point, since they already released the percentage breakdown. No, it's anything from unit 1 through 7.5 for us, which means anything from kinematics all the way to shim, excluding sound and circuits. So everything from kinematics to shim is fair game. Okay. All right, and then I'll give you some probable exam type questions as we move forward. All right, so there's your test. It's an online test. It's assumed to be open notes, so use your 3-ring binder if you need, or play it on hard mode for the achievement points. No outside help, so don't be Googling stuff. They've said a lot of weird things, very vague things, as in while you're using that platform, they'll figure out if you're cheating or not by looking things up online. So I'm assuming you'll be tracked. If you type anything online, even if you think you're using some alias and no one can track you down, they can, and they are ready to hunt you down if they need to, and they will. And since this is the college board, all the colleges that you've applied to or planning on applying to will know that you're a cheater or something like that, and this will come back to hurt you in the long run. So take it seriously. Just because it's open notes, don't start talking about the questions online. Don't try to make memes and whatnot, and don't post on Reddit. Keep the questions to yourself. Take it just like you would a real AP test, right? You would be in Anderson Hall by yourself. It's freezing cold, and no one to talk to, etc. So find a quiet spot for 45 minutes or 50 minutes, whatever it is, so that you can take this test. Yes, and for those of you who have siblings that like to randomly open up voice chat or whatever, voice messages, make sure you tell your siblings to not to disturb you during the time you're taking this test, so that nothing opens up on your computer out of your control. A certain someone told me that that's what happened during their Canvas quiz. Interesting. All right, so 2 questions, 60-40 split, tipper style, justify style, and then paragraph length response. So not much calculations going on, but you can use calculations and formulas and laws and rules as part of your justification, right? So it's expected that you do all those. Step 1 in doing well, just draw an FBD. If it involves forces, definitely do an FBD. All right, so that's the AP test, at least the plan. As we get closer and closer, we'll get into the nitty-gritty details. They haven't really released the information of the platform and the software that they're using, but eventually I will get that information, and then I'll do a tutorial, like a walkthrough video, and we can even practice. So it's not like the first time you're doing it. So we will practice to do like a mock trial before, of course, the AP test, so that we are ready and we're comfortable using the platform. All right, so let's go and continue on where we left off. Finals review 2. For those of you who have done your spring break homework, the last FRQ question that is asked is different from the solutions that was given. The solution was about like a static equilibrium problem. I've uploaded a new test, so you can take a look at the new number 5, and it will match up with the answer that is given. So the check test number 2, test 2, FRQ 5. So do that one. Give yourself, no more than 15 minutes. So do that one in less than 15 minutes. And then you can grade yourself with the actual answer key. Okay. But since you saw the first iteration, let's go and talk about it so that you know if you did it right or not. But I do want you to do the new number 5. I think my chair is kind of squeaky. I need a new chair. Do the new number 5, and then take pictures of your work and upload it to Canvas as a PDF. But let's go and do this question number 5. So the iteration number 1, we'll call it version 0 or version 1. This is version 2, V2. Version 1 has 2 speakers that are playing slightly different sounds, frequencies. The first one we know is 350 hertz. The second one we don't know what it is. We'll call it F2. Okay. And it says in a paragraph length response, can we figure out what the second frequency is without any kind of instruments, right? All right. Can someone verify this is the question, the version 1 question that is no longer online? Those of you who have done it, chat. There's one, of course, Emma. Yes, Emma was the one who emailed me. Good. So this is the version 1 problem. So 2 speakers that play different sounds. They're slightly different. So that word "slightly" is important. When your frequencies are slightly off, okay? When your frequencies are slightly off, and you listen to both sounds at the same time, what do you get? If you're here, you get frequency from this one, you get a different frequency from that one. They both hit you at the same time because the speed of sound is independent of the frequency. It's dependent on the medium, which is air, which is 340 meters per second, thereabout. If your frequencies are slightly different, what phenomena do you get? A beat frequency. Yes, you get a beat frequency. Now the reason why I want you to do the version 2 is because version 2 FRQ number 5 is like dynamics, which is more likely to be on the AP test, whereas this sound question is not. But I just want to do this anyway because some of you still want to go into the STEM field, and eventually you're going to take physics or something related in college, so it's good. And if we do have a test on finals day, we would sound and circuits would be on the test. All right. So you get beat frequency. So what could you do? Well, here's my solution. Let's go and stand between the two frequencies. Between the two speakers, and then you just stand there, and then you hear your beat frequency. We know that the beat frequency is either 5 higher, or sorry, not 5, but like some amount higher or lower. Essentially, F2 would be equal to F1 plus or minus the beat frequency. Recall the wow, wow, wow effect that we get. So you stand in there and count FB. Stand in middle. And count FB. Count the beat frequency. Right? And so let's say you counted, hypothetically, you counted 5 beats per second. So this F2 could be either 345 or 355. Right? So now we want to figure out which is the case. Which one is it? Is it 5 higher or is it 5 lower? Okay. All right. So the next trick is to just walk forward. So let's say you just walk forward at 1 meter per second towards the unknown speaker X. Okay. Remember, we just hypothetically chose 5 being the beat frequency. Whatever it is. Of course, you could do it in variable form also. Let's say you start walking towards. Now we can incorporate, because we have relative velocities in action, we can incorporate the second phenomenon, and that is the Doppler shift equations. Doppler shifting effect. If I am moving towards this speaker, what happens to the perceived frequency? What happens to F2 that I sense? Chat, what happens to F2 when you walk towards the speaker, the source? Step 2. The frequency increases. Good job, Bubble Guy. So if I'm going towards this unknown speaker, we know that the frequency will increase. And if I strategically do it at a meter per second, 1 yay per second, then we can actually get numbers, and we can do it with numbers later. But let's just do it conceptually first. Notice that if I'm going towards the speaker, it's going to increase both. The 345 would go up if it was 345, and the 355 would go up if it was 355. Right? What happens to the other one when you're moving away? When you're moving away from the speaker, in the away situation, the reverse happens, and the frequency decreases. So this is going to go down by a certain amount. Okay, since you're going at 1 meter per second, it's gonna slightly change. Okay, so let's see. F2. F1. Let's call it F1. F1 was the 350, so this is F1 prime. F1 prime would be 350 times the speed of sound, 340. Since we're going away, we're going to use the minus plus situation, so minus velocity of the observer, which is 1, divided by speed of sound, 340, plus the speed of the source, which is 0. And this gives us 350 times 339 over 340. So 339 divided by 340 times 350. It's just one lower. 340. Okay. So this one is 349 now. What happens to F2? Well, for F2, we're going towards F2, so it would be speed of sound plus 1 divided by speed of sound, because the observer is moving towards the source, which is plus 1 at the top. The source, which is the speaker, is not moving, therefore it is 0. Frequency decreases, right? Yeah. So let's say it was 345. If it was 345, the new one would be 346. If F2 was 355, then the new frequency would be 356. Okay. So now we can take a look at the beat frequency. If the beat frequency was between the 345 and the 350, okay, notice how FB is now less. It's only 3 hertz. Whereas if it was between the 350 and the 355, the F beat is now more at 7 hertz. So if you're walking towards, is that Sword Hero? No, Sword Hero, you deserve the ban. You need to repent. You need to think about what you did wrong. Think about why I banned you, and think about how you can promote the physics image no matter where you are, no matter where you go, with or without me. You don't need me to tell you how to behave. I need you to do that on your own. So I'm going to give you some more time to think about your past transgressions, and then eventually I may unban you. You paid for yours. We'll see. All right, anyway, so as you can see, if it was higher, if it was 355, the beat frequency would increase. If it was lower, the beat frequency would decrease. So based on the change in your beat frequency, you can figure out what the actual frequency of F2 is. Yeah. All right. So that was a cool question. I thought that was fun. So this is like low tech, no technology, nothing, purely conceptual base. We can definitely count beat frequency. That's really easy, only because we know that the frequency is slightly different. So it's either in probably single digit numbers or whatever it is. Easy enough to count. So stand in the middle, count beat frequency, and then walk towards the unknown. If you walk towards the unknown and the beat frequency goes up, you know it was higher. If it goes down, then you know it was lower. All right. So we finished off kinematics. Well, at least we did the classic kinematics problems. The last classic problem was the police chase problem. The last part of kinematics would be graphical analysis. So a lot of you, you guys did it for the first time ever. Even the BC kids, you haven't done this quite yet at the time, so it was kind of challenging. But now that you've done it, it's probably a lot easier. The relationship between derivatives and integrals and all that. But for the rest of us, we just did it purely conceptually by looking at the value of slopes. Recall that x, let's say x is displacement. So delta x Delta t is your average velocity. Okay, and recall that it's also equal to v0 plus v final over 2. If a is constant. If your acceleration is constant, then you can do that. And of course, delta v over delta t was acceleration. I'm going to call it average acceleration. Okay. Relationship of graphs. This is displacement versus time graph, or position time graph, PT graph. Here we have x as a function of time. When you have an x as a function of time and you have a graph, recall you can just take the slope, so like so. Now, what is the y-intercept? Okay, that's your initial position. So this is x of 0, which is x naught, which is the initial position. Okay, and then you take the slope. Now, when you take slopes, especially if it's given as as data from a lab or something, so recall that your graphs are just scatter plots. There we go. You get random points, and then you use your best fit line to draw a line like so. Okay, and so if you're trying to find the slope, do not use the actual data points, like the actual points that you plotted. Pick points from the trend line itself. So pick points from the trend line. So pick a point from the trend line and try to space them out so they're not like right next to each other. This will give you a better average. And then find the slope using slope formula. Now, so recall that your AP test will be, justification and other things. So what kind of things can they throw at you? Well, for example, they might have like student A found the slope by taking points 2 and point 3. Why is this slope a worse approximation than some other thing? So you can talk about how by taking the trend line you get a better approximation, a better average of what the slope is. By choosing points that are further away from all extremes, you're more likely to get a better answer that way as well, because it approximates it closer to all points, not just some points, etc., etc. So anyway, if you do take slopes, make sure you take it of the best fit line. The slope here gives you the average velocity. Oh no. Slope gives you v bar. Okay. All right, now, and then we can move one step further. If you have a velocity time graph, so pay attention to what kind of graph. Pay attention to the y-axis. If it's meters per second, it's velocity. So velocity as a function of time, versus time here. And you can do the same thing. If I were to graph this, notice how the slope is some value that never changes. The rise over the run is the same, and therefore it would be some value that is positive, and it stays constant. And we want to make sure it's aligned properly. So whatever this value is, T final, would have to be here, T final. Okay. All right. And finally, we can take the slope again. Slope again. The slope will give us the average acceleration. So this is a as a function of time, in meters per second squared. This is in seconds. This is meters per second. This would be meters. Ooh, I need to drink some water. All right. The slope is a constant positive. Actually, yeah. The slope from the position graph was a constant positive value. The slope from the velocity graph is 0. And so it stays at 0 all the way to T final. All right, so easy stuff. If you want to go backwards, it's a little harder. But in any case, look at the value of the slope. The value of the slope will tell you what what each value at each point is, or like draw little tiny lines, etc. So to do it without calculus, let's see if we can do it without calculus. So if I start with some, let's see. Ooh, we'll call it negative 9.8 meters per second squared. Ooh. All right, so here's our acceleration as a function of time, and it's a constant value for a certain amount of time at negative 9.8. So if I want to go backwards, velocity of time, velocity as a function of time, how do I do it? We'll have to look at each little point and see that every point gives you the same slope value. It's the same slope value for our velocity. Is there a derivative of acceleration? Yes. Jerk. Displacement, velocity, acceleration, jerk, snap, crackle, pop, and then after that it's meaningless, or physically meaningless. Alright, now you do need to know what your initial condition is, right? For those of you in calculus, you know that when you're taking your integral, you have to have some sort of initial condition to get the this plus c value that you get. That c value, the plus c, when you take your integral, is the initial velocity in this case. So let's let initial velocity v0 equals 0, starting from rest. So if we start from rest, our initial velocity is 0. And this tells us that the slope at every point is always a negative 9.8. So what does a slope of negative 9.8 look like? Well, it's a rise over run of negative, or fall over run. I'm going to fall 9.8 and move 1 to the right, etc. So like this, and then when I'm over here, it's continues. It's the same slope, and it keeps on going. Blah 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 blah. all the way to t final. All right. And then we go up 1 again for displacement. Okay, this is where it gets slightly harder. Here the value is always the same, so the slope stays the same. Whereas here the value is decreasing. It's negative 9.8 here after 1 second, whatever. What's the velocity after 2 seconds? Well, after 2 seconds it is 19.6. So that means it is a far steeper. Is there? It's a far steeper slope, far steeper negative slope. So we start off with a small negative slope, but then as time moves on, the slope gets steeper and steeper and steeper. So you can see how it curves like a parabola. Okay, so that's just doing it conceptually. Are you going to have to do this on the AP test? Probably not particularly this way. You might have to perhaps, know it conceptually, so that you can, compare and contrast, or, do all sorts of cool stuff like that. If it's a lab design question, so let's talk about lab design question with kinematics involved, right? What's one way? So can you design a lab to get this graph? I'll give you a moment to think. Design a lab to get this upside down parabola using the, hint, 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 using whatever lab equipment we used this year early in the semester, semester 1. Okay. Is there a way to get this upside down parabola graph? Hint number 2. What's something that has a nice negative 9.8 meters per second squared acceleration with a where the object starts from rest? I lost like 7 viewers after that. A motion detector observing a falling object vertically. Cool. So we can use our Logger Pro motion detector. Here's our hub. And then the hub connects to your laptop. Here's your trackpad. Here are the keys. RBG keys, of course. And this motion detector, recall, has like a speaker thing. It's basically using Doppler shift to figure out where your object is and how fast it's moving. Now, ideally, we want to protect our motion detector. So in the past, we've done this before, where we put a wire cage. But the wire cage has big enough holes so that the speaker is not blocked. Otherwise, the motion detector will try to map the position of the wire cage, and the position is not changing, right? So you have to make sure that the wire cage has big enough holes so that the sound can travel through unhindered. And so now you can drop a ball and drop it from rest, let it go towards, and then now, of course, when it hits the wire cage, you're going to get a weird spike. Right? It goes from a very high negative velocity to a quick 0 and goes the other way because there's an impact force. And we'll talk about impacts and dynamics later on. But yes, so a falling ball with a motion sensor will give you this graph. At least the position graph. Alright, I guess that is all for today. Thanks for tuning in. Go ahead and upload your homework make sure you do the new question number 5. The answer is the answer to question number 5 is already up there. I just changed the test, so now you it's not about the speakers, it's about the tension cable and stuff. It's a simple static equilibrium problem, and you'll see that we've actually done it in our notes. We've pretty much done everything the College Board can throw at you. Hopefully, that's the plan. Now it's just putting it all together. All right, I'll see you next time. Do we have to show work for the MC? What are we reviewing tomorrow? So we just finished Kinematics 2D. Tomorrow would be start of dynamics. Do we have to show work for the MC? Yeah. You should have taken it as a test, right? And then after you take it as a test, whatever work you have, keep it. And then what you're supposed to do is test corrections. So you have to upload your test corrections along with what work you showed for when you took your test. Remember, you're supposed to time yourself. If you didn't do it, well, it's going to take you like 6 hours. Good luck. It's due at midnight. All right, so your test work, your work that you did while taking the test, and then all of your test corrections on top of that. And then give yourself a grade. Use the grading mechanism. Is there a grading mechanism? I don't know. Just it's somewhere around 40% is a C or 3, and then 55 or something is like a 4, and then 72 is like a 5 or something like that. All right. See you later.